we'll check the solution at the end. So we have 3x plus 15 equals 3x plus 15. I used the distributive property, multiplied the 3 over the x and the 15. Well, at this stage, actually, I see both expressions are exactly the same. So let's see what happens when I go ahead and solve it. Well, when I do that, x's all cancel out. See, the 3x I canceled out from the right side. It canceled out the x's on the left, and it left me with two numbers that equal each other. This is called an identity when we have two numbers that equal each other. And what it means is that we have infinitely many solutions. So there are so many that we can't even count them. We can put any number in for x, or yes, in x in this case, and it will give us a true answer, or true solution. It will give us an identity. On this next one, if I multiply a third by each of these numbers, I end up with 3x plus 1. So basically, when I multiply a third, I'm dividing 3 by each of these terms. And on this side, I have exactly the same thing, 3x plus 1. Now, let's pretend this is a plus 2 instead. Let's change the problem just a bit here, just to make it a little bit different. So I'll bring down this plus 2. When I go ahead and subtract the 3x from all sides, I'm left with, well, the x's all cancel out. And the reason why I wanted to change that to a 2 is to make it not an identity. We already had an identity over here, and we knew the answer would end up being infinitely many solutions. But in this case, when I changed this to a 2, it made that this case where we do not have an identity. We have an untrue statement. And so this is called, the answer would be no solution. There is no number in which I can put a value in for x and get a true statement, an identity. And so this would be a no solution. Looking at this next problem, it says satellite TV provider A charges $75 for installation. Okay, so that's like a one-time charge. You only get installed one time. And $39.95 per month for basic package. Provider B, okay, so this is letter B here, so we have two of them. We have A, and they charge $75 and $39.95 per month. So I'm going to say M equals the number of months. So now I've got an idea about what I've got here. So let's see what B offers. Free installation. So there's no charge for B. So no charge there, and $39.95 per month. So plus $39.95 each month. And so for the basic package, so same type of package. Your neighbor subscribes to provider A. The same month you subscribe to provider B. After how many months is your neighbor's cost the same? So cost the same right there. That's where I use the equal sign. So to the total cost of provider B. So let's go ahead and solve this by moving the m's to one side to find out the difference in the monthly charge. But when we do that, we see there is no difference in the monthly charge. Those monthly charges are 0. So now we have this difference. Provider A charges the $75. Provider B charges no installation. So we will never have the costs be the same. So there is no provider A will always charge more, $75 more, because they had that initial charge. So this again was a no solution. We didn't have a solution. We couldn't find a value of M where they would charge the same, and so that's what our answer would end up being right there. Let's take a look at this one. It says a blood sample, the amount of red blood cells in a blood sample is equal to the total number in a sample minus the amount of plasma. Alright, so we're going to have to subtract that out. What is the total amount of blood drawn? So we've got to look to this example over here. And so we have the amount of blood drawn. Let's use a variable there. So I'm going to go ahead and call x equals the amount, and it even says there, amount of blood drawn. And then we're going to go ahead and set up our equation. So x, and then it says minus the amount of plasma. Alright, here's the amount of plasma right here. Minus 5.5. And then it says is equal to, so it's equal to And the amount of red blood cells. Red blood cells right here, 45% of X. So 0.45 X. And so I've got the total amount of blood drawn is everything, the red blood cells and everything else. And so we go ahead and we subtract the X from both sides. So I'm taking X away. Now think of this as 1X, so 1.00. So when I do this, I've got 0.55X when I do that subtraction, and it's negative equals negative 5.5. And so when I divide by negative 0.55, the decimal point moves over 2 spaces. I move this one over 2 spaces, and so it's really 55 into 550, and that would go 10 times. So 10, and then the units, milliliters. See right here are the units that I use. So 10 milliliters is the amount of blood drawn. So those are the types of problems you're going to see on the homework. Good luck.